This question is a Leaving Cert Higher Level Project Maths question from 2014. In part 1, we're to find the dimensions of this box. The dimensions are the height, the length, and the width. Let's consider the diagram. We see h, the height, applies to these sections in pink. I'm going to color in yellow the lengths, and I'm going to call the other dimension the widths. I'll color those in green. So there are 3 dimensions. We also see there's little flaps on it, and in the question it says the flaps are 1 centimeter long each. Now if we consider that the total side here is 22 centimeters, that means 22 must be 2 h's plus a w plus 2 of these flaps. This gives us that the width is 20 minus 2h. If we go across the other way, we see that 31 is equal to 1 of the flaps plus 2 lengths plus 2 h's. So we see the length must be equal to 15 minus h. This is the answer to part A. In part B, we want an expression for the volume of the box. The volume is length by width by height. We're going to use our answers from part A here. And we can leave it like this. We don't have to multiply this out yet. Okay, part C, we're to show that the value of h that gives the box a square bottom will give a correct capacity. Okay, let's consider both these ideas. Now the correct capacity, it tells us in the introduction, it has a capacity of 500 centimeters cubed. And if you consider that the bottom is square, that must mean that the length and the widths are the same. So let's write this down. The width is the same as the length, and the volume is 500 centimeters. Now if we use the answer for part B in terms of volume, this tells us that, well, firstly 15 minus h, the width, is equal to the length. And that tells us that the height is 5. So if we sub 5 into this formula for volume in part B and take out a calculator, we see that yes, it does give us a volume of 500 centimeters cubed. In part D, we'll find to correct 1 decimal place another h that gives the correct volume. Well, we have h in terms of its factors here. So if we expand these out, we know that the volume is 500 centimeters. Multiply it out to give us a cubic equation. So I'll multiply the h by the 15 minus h in the first part, and now multiply out this binomial. And we let it all equal to 0, taking 500 from both sides. And we see 2 divides across. So the neatest way of writing this cubic is h cubed minus 25h squared plus 150h minus 250 equals 0. So this is a cubic equation that we need to solve. To solve this, we would need one maybe integer answer first, and we have that already because we know that h equals 5 works as a solution. So h minus 5 is a factor. So if we divide by this factor into the cubic, it will give us a quadratic expression that we can solve. So set up our long division. H goes into h cubed, h squared times. Multiply it out. H goes into minus 20h, minus 20h squared minus 20h times. And lastly, we see h goes into 50h 50 times. And we see this goes in evenly. So now we have this quadratic to solve. We know that h squared minus 20h plus 50 is equal to 0. Now we did say to one decimal place, so that suggests we're going to use a quadratic formula. In this case, a is 1, b is minus 20, and c is 50. So carefully putting in the values of 1 minus 20 and 50. You could use a calculator earlier on in this, but it neatens down to 10 plus or minus 5 root 2. Subbing this into the calculator, we get the h is 17.1 or 2.9 centimeters. But the 17.1 makes no sense because one of the sides is 15 minus h, which would make that side negative. So accept 2.9. Okay, in this part of the question, we want to increase the volume of capacity by 10%. So at the moment, the capacity is 500 centimeters cubed, and increasing that by 10% will bring it up to 550 centimeters cubed. Now the only way of relating this to the graph is find 550 here on the graph, and we'll go across till we meet our curve and down. And we see this gives us a height of around 17.2, which again makes no sense for the same reason as the last one, that we can't have a width of 15 minus 17.2 or a width of minus 2.2 centimeters. So that height is too large. Hope this was useful. Thank you.